except it's still frozen. That's anticlimactic. There we go. Okay, number 14. You're supposed to get y by itself. When you got y by itself, you should have been able to graph. Now here's the funny thing. They don't even show you y by itself. That's kind of silly. Let me go ahead and write for you really quickly what you should have gotten, although you guys should be able to help me. What is y by itself? Y is greater than or equal to who? Yeah, I would do negative 5 thirds x. That's probably the easiest way to think about it. You're right. It would be negative 5x minus 15 over 3, but you wouldn't really be able to graph it unless you got the mx plus b part. Then I think we end up with minus 3, right? Nope, minus 5. I divided by the 5 instead of the 3. Now do you guys agree? Okay. So intercept at negative 5. Slope is down 5, right 3, or back 5, up 5, and back 3. Either way, negative slope. And then why is it solid? And why is it above? Yep, you can use the trick. But what would have happened if you had plugged in any of these points? They all would have been true. The true ones get shaded. The false ones don't. Number 26, that was just a plug and chug to your calculator, but you couldn't have plugged it and chugged it until you got y by itself. Just a few of you would have the shading in the wrong place. Why? If you didn't flip the inequality when you divided by a negative. If you didn't flip, you've had the shading in the wrong place. It should be below. How many of you guys tried to remember last night the inequals, turning it on your calculator? Oh. You could have turned on the inequals in the apps menu. Remember, you can put the little less than in your y equals, right? You can put the little less than in, but hold on. If you hadn't switched it, would you even have had the right thing to put in your calculator? So be careful. You got to do some of this by hand, right? But graphing it and then shading below, and you didn't need your calculator to. Some of you are like, whatever, it's less than, I can do it on my own. And actually, to be honest, it's kind of nice not to have the inequals. If you don't know what I'm talking about, the apps button, the inequals, we did it in class. It lets you change the equals to less than or greater than or less than or equal to. But why is it nice not to have that turned on? And some of you might want to go apps, inequals, and quit it or discontinue or whatever the option is. You can't use your alpha y equals fraction shortcut when you have it turned on because the alpha is being used for something else. And to be honest, there are a lot of you that if you needed to go plug in something to your calculator like, I don't know, 5x. Someone came up against this. I think it was a calculus kid. They were borrowing a calculator where someone had turned it on. If you tried to plug something like this in and you were trying to do like a less than or equal to, the struggle is a lot of you wouldn't think of, because you can't use the shortcut when this is turned on in your calculator. A lot of people would just do this. And guess what? It'd be wrong. Because your calculator does PEMDAS, and it says, okay, I'll divide, then I'll add. What your calculator sees this as is 5x over x plus 1. And are these the same? So you'd be wrong. So the struggle is, I love that shortcut because it lets you organize everything and not have to remember that every time you do it the long way, you have to put parentheses around any sort of denominator with multiple terms. And similarly, if we had something like up here as well, you would have to do the exact same thing with any numerator. You have to put parentheses around it. So I don't know. If you like inequals, I suppose you can turn it on in the test, but just a heads up, you won't be able to use the fraction button. And if you don't use the fraction button, you have to put parentheses around numerators and denominators, or else your calculator is going to get it wrong because you told it wrong what to do. Okay? Number 44. Could you have used your calculator? Yes, but what would you have had to do? Did anybody do it? I mean, you could have, but what would you have had to do? AJ? Right. Did you get a half circle? Okay. How did you try to put it in your calculator? Good. Can I do this one real quick? If you got y by itself, I mean, this one would still be a little tricky. You'd have to flip that. but hopefully it wouldn't have been too bad to subtract and then divide. Guys, where does it get tricky, or even AJ, where did it get tricky to get y by itself? The square root. If you see the squared right now, the square root. I don't know what's going on, but okay. If you got y by itself on this one, it'd be y is, and here's where some people have gotten messed up, plus or minus square root of x squared plus 25. My guess is that you were trying to make it easier on yourself in the calculator and you wrote x plus 5. Maybe you didn't. But if you did write x plus 5, that would have been a line and not a circle. Do you guys see how some people might make the mistake of just putting in x plus 5 because they're being lazy? Or not being lazy, being smart? It would be negative x squared. Thank you, thank you, thank you. So negative x plus 5. Why am I not allowed to do anything with the square root and cancel anything out? It'd be killing the puppy. And more specifically, I mean, I've shown you this tons of times this year, but I guess just for another reminder, wouldn't this factor to be 5 plus x, 5 minus x? Can't we only cancel out square roots if we have a squared? And do we have a squared? Are these the same? No. So can we cancel out the square root? No. But here's the other struggle. If you guys were like, no, I knew my math, I wouldn't have canceled out that square root. Okay, well, if you didn't remember the plus or minus, guess how much of the circle you would have gotten? If you didn't do the plus or minus, you just did the plus, you'd only have half a circle. How do you get the bottom half? You need to write y1 to be the positive, y2 to be the negative. There is no plus minus button in the calculator because these are two separate functions. This can't be a function. It would fail the vertical line test. I need two separate ones put together. And then the y3 would have been the 4/3 x plus 0, which is just 4/3 x. That's what you would have had to do in your calculator. But does that seem kind of work intensive? A little bit. Doesn't mean it's impossible, but a little bit. Then you could have done with your little less than or equal to's, greater than or equal to's. The struggle on this one is that for the positive one, you would have kept the sign less than or equal to. For the negative one, you actually would have had to flip the sign because it's really like you're doing a positive, negative, and dividing. You would have had to flip the sign. And then y3, you would have had to do, just keep it the same. From solving, which was flipping. Anyway, I'm not exactly sure that saves a lot of time to do all that in your calculator. It might be easier just to say, hey, he's a circle with a radius of 5. Dun, 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 dun. He's a line. And maybe gotten him by itself to show he goes to the origin and goes up 4 and over 3. Dun, 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 dun. If you had graphed it carefully, maybe you could have found the intersection points to be 3, 4, negative 3, negative 4. The shading, you go above the line, the circle. This is a little confusing, but you could have tested a point. And if you tested 0, 0, or 1, 1, or 2, 2, all of those would have worked, so you would have known, oh, hey, I'm going to go inside the circle instead of outside. This is one of those where the less than, greater than shortcut doesn't work so good. But the testing points works great. But also you can know if it's a circle, less than always means inside, greater than always means outside. You could make a note of that if you would like. And if worst comes to worst, and if you weren't able to find the intersections any other way, I suppose you could have done a let's solve for y and plug in and do a substitution, factor the quadratic kind of thing. That would have worked. Okay, some of you love your calculators, but I'm just trying to show you can't just depend on them. They're not always easy, and sometimes they're actually harder. Number 54, I think he's our last one. Yep. Why was this one hard? I thought this one was hard. Yeah, they gave you the graph and said, well, make it yourself. Did you guys notice on your graph they gave you 2 points for each line? And what can you do with any 2 points? Point slope form, make a line. Or maybe even you could have maybe jumped to slope intercept form. I like point slope. Jacob, you're totally right whenever you're given points. But to be honest, they were super nice with the points they gave you because remember, isn't this guy the y-intercept? So you could have actually jumped straight to, oh, they gave me B. Oh, they gave me B. And then for M, you could have done rise over run, y2 minus y1 over x2 minus x1. You could have found m, y2 minus y1 over x2 minus x1. Negative 2 over 8, which is negative 1/4. And they wrote them kind of funny, but whatever. It's the same thing as negative x plus 4 and negative 1/4 x plus 2. I mean, you could have just plugged straight in. They just wrote it kind of weird to make it look nice with the negative. But then once you had those equations, then you just have to go ahead and look at the shading and say, oh, hey, the shading was above both of them. They both were solid, so greater than or equal to on both. And then, did you guys figure out what those two were doing? Those were kind of hard. Whenever x is greater than 0 and y is greater than 0, x is positive and y is positive. What quadrant are we in? This condition always gets us to the first quadrant and then goes ahead and deals with whatever else is left. So in the picture that you looked at, there would have been more that would have been shared if it had been allowed to go outside the first quadrant. But if you looked at the picture, it was only in the first quadrant. That's why they went ahead and put those two conditions. If we had done section 7.6, you would have realized this is super important, because if we're doing like a businessy problem where some company is making like two different products, one would be how many they're making of product A, and then Y would be how many they're making of product B. This is very common in business models because you're not going to have negative products that you're making. Does that kind of make sense? You would automatically say, well, the products have to both be positive. Okay, cool. First quadrant. Now let's graph all the constraints, all the different conditions. But we're not doing section 7.6, so we're not going to really get any better at that. But I wanted to show you guys. This little guy was just saying, oh, yeah, and by the way, it was only in quadrant 1. All right, cool, kids. Any odds that we got stuck on? 63. Cool. Anything else besides 63? Don't worry, I have the book. I'm going to go look at 63. But if you guys come up with something else, let me know. Okay. 63 was a businessy one. You guys saw there were tons of businessy ones I could have given you, right? Okay. 63 was a businessy one without lots of words, but you did have to read the directions. Graph the systems representing the consumer surplus and producer surplus for the supply and demand equations. Okay, we have equation 1. We have equation 2. Now, what do you guys think? Looking at these numbers, do you think I expected you to do this by hand or by calculator? Oh yeah, definitely calculator. Okay, so if we went ahead and plugged that in, because how would you do a slope of 0.00002? I'm not that crazy. I'm crazy, but not that crazy. Oops, that's not what we want. There we go. Let me close out of him because we don't need him anymore. Does anybody notice how steep those two equations are going to be if the slope is 0.00002? How steep is that? Barely. Because the slope of 0 would be flat, right? So 0.0000000 whatever, 2 is saying, wait, how many zeros is that? 4, right? Okay, so all those zeros are standing for powers of 10, right? So if we have the 0.0000, that'd be tenths, hundredths, thousandths, 10,000ths, 100,000ths. It says go up 2 and go over 100,000. Whoo! That's like, we didn't even okay, I don't even know. So the struggle is if we go to our y1 and if we try to graph both of these, which we could do, let me get rid of all this, guys. See how much I like my alpha y equals fraction shortcut? I use it in all the classes. It's a great shortcut. Poor inequals turns it off. All right, AJ, what'd you get for the first equation? What's the demand? Four, right? X? Cool. And then my supply, oh, he's right there. It's the third one, right? 80 plus 0.12341 x. What's going to be the problem if I go to graph this right now, guys? And I'm probably in Zoom. Yeah, it's just going to look like two parallel lines because it's like, well, hold on. I'm going to see nothing because what are my y-intercepts if I have 80 and 140 in front of my x term? Yeah. Well, stink. My window's not even close to that. I have to make my y's go up to at least 140. Let's go to 200 to see it. But even if I make it so I can see the equations, why do they look parallel? They're barely slanted. Of course they'll look parallel. There's not even near enough pixels to be able to show you the difference. But here's my question. If the slopes are different, will those two lines intersect? Eventually. How long is it going to take? Whew. You could solve the system of equations and figure out the point of intersection. AJ, did you find the point of intersection for this guy? No? Okay, well, guys, hold on. Wait, we got this, right? Point of intersection, I mean, I know that doesn't look pretty, but couldn't we just multiply this guy by 2 and then add the two together? Check it. 1, 2, 3, 4, 2. 1, 2, 3, 4, 1. Couldn't I just multiply him by 2? Right? Then system of equations, I could do elimination. So then I'll end up with, if I were to keep on solving, see if I can remember what that function was. That's not what I wanted. Undo, add. Number, what are we on? 63? My demand and my supply. I have P equals 140 minus 0.00002. And I have P equals 80 plus 0.00001. Double check me, but I think that's good. I could have multiplied that guy by 2. 2P equals 160 plus 0.00002x. See why I multiplied by 2? Now what? 3P equals 400, yeah? No, 300. Thank you, thank you. So what does P equal? So P equals 100, which is like the Y value. When X equals, struggle. Wouldn't we have to go back and plug it in? I need someone with a calculator close and handy to help me out. If we plug in P equal to 100, back substitute equals 80 plus 0.1, 2, 3, 4. So to subtract 80, I need to figure out. Yeah, it is going to be a big number, right? That's why I'm trying to get you guys to figure it out, because I have to change my window to match that, and I don't know how big to go. Right? Because I'm going to have to 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. There we go. So is that right? Is it 2 million? Or is it 200,000? I might have, struggle. Yeah, I did it off one. Sorry. There we go. Okay. So at 200,000 is my intersection point, but to be honest, kiddos, I want to go beyond that, so I'm going to go 500,000. And all of that is because this problem was having us find what we would call the market equilibrium point, find the intersection point. And then if you guys had looked, I just did the wrong one, didn't I? I just did Y, struggle. Lo siento, I want my X's to be the 500,000. The 200 was more than enough for my little graphs. There we go. Now we see that guy going down. We see that guy going up. Are you guys sure it was 200,000? Sure doesn't seem like it. I think my 2 million was better. I'm going to do 3 million. 1, 2, 3, 4, 5, 6. I was thinking it was put 5 extra zeros on. Let's see if we see it now. There we go. He's going down. He's going up. There's my intersection point, which we could find by doing just a quick second graph, intersect, first curve, second curve. I only have 2. Go find him. The intersection point is what we found. Aha! 2 million. You guys. Did you divide it by 0.00001? It's okay. It's easy. There's so many zeros, right? 4 zeros and then a 1. And then you should have ended up with 6 zeros. And it's 20 divided by, not 2 divided by. Okay. So we end up with our intersection point. That's what we call the market equilibrium. The problem was asking for the producer and consumer surplus. You guys might have been like, this makes no sense. Kiddos, if homework ever makes no sense, what should you probably go looking to first? The notes. To see if we did an example. Yeah, that's the sad part. The notes to see if we did an example like it, because we usually do. And then second of all, the book to say, hey, is there a problem really, really similar? Oh, look, it tells me everything. Make the graph, get the intersection point, shade, and say, oh, that's the consumer and that's the producer. Dun, 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 dun. Crazies. So all you had to do was draw a little line and say, dun, 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 consumer, surplus up there, producer, surplus down there, market equilibrium point right there. Is this econ? No, but are we trying to apply the math that we're using or learning at least a little bit to something practical? Yes. The example was right there waiting for you to look at it if you had just tried. All right, cool kids, with that, we are done with section 7.5 questions. 7.6 we are skipping, which means it is time for us to go peek at the review. Some of you guys were working on it last night. Maybe they can help us out in case they got any questions that they got stuck on. Real quick, though, before we go to that, let me pull up, I think I have it right here, Chapter 7, Precalc. It wasn't last night, but it is now. All of Section 7.6 is crossed out because we are not doing it this year. But what else is crossed out in the review? The 7.6 problems. Yeah, that makes sense, though, right? Cool. All right, review questions. Anybody have any that they got stuck on that they want us to look at? Lainey.
The only one is
51. Anybody else? All right, let's go peek at it. If I were you guys, oh, we'll get one from spirals. If you're not ready to do this, no big deal. Why don't you write it down in your workspace? You can go back and reference it when it's time. Joel, wake up, bud. We're going in the back of our who has not gotten to the review. I guess you could do notes. It's kind of out of order. I don't know. Might be nicer in the, because it's the review questions. We don't have a review section of notes. Ruth, what else? 43. AJ, you have another one?
Oh, no. I was just asking what that is.
Oh, 51 and 43 is what we're looking at in the review. Let's do 43 and 51 all together, or at least peek at them and me give you a hint. 43 is the first one. Oh, that's a great question, though, to ask. That's a great question to ask. Kiddos, this is from section, if you don't remember, section 7.3. Row echelon form, the stair step. They were nastier problems than the substitution elimination ones of 7.1, 7.2 because now there were how many variables? 3. And some of the nasty ones had 4. I don't think you'll see any of those on the test, though. You had 3. Okay? What's weird about this? They're calling it a non-square system. What's weird about them? There's only 2 equations with 3 unknowns when we really want, for any set of 3, we want 3 equations. In our notes, and maybe Ruth can help us out, but hold on, let's let everyone think or brainstorm just for a second. In our notes, we talked about what to do either when solving a guy like this, and you get down to, remember, take the first 2, take the second 2, get rid of x's. Take the y's and z's, get rid of y's. You're trying to get z equals a number, right? But every now and then there was a weird one where z canceled out, and you had 0 equals 0 or 5 equals 5. So sometimes it looks normal, but z cancels, and you're like, wait, what? That's possible. Do you remember what to do when z cancels, which is the same thing to do if you're missing the third equation? Lainey? Yeah, good. Let z equal a. Some of you are remembering it. Let z equal a. Because we can't, if z cancels, we can't say z is a number, so we say, okay, fine. Z is any number, and then. So, Ruth, did that make sense, the z equal a part? Okay, but she was like, I don't know what to do after that, or she got stuck after that. So let's go ahead and take this hard example from 7.3, which is a great one to do. I'm going to go ahead and just make a new page and just call it review questions, since our notes are kind of out of whack since we're skipping the end. Okay. That's not the right thing. You guys want to go do calculus? No? Not yet? All right. Okay. So number 43. Kiddos, check it out. I want you to look at it, and most of you haven't done it yet, so I'm just curious, what would you do first? Okay, be impressed by my little whiteout tool. But otherwise, now what? What would you do first? Right? We take the first two, and we want to get rid of who? So what do I have to multiply? Come on, elimination, 7.2. Okay. Oh, not 3 and 5. Okay, remember, one of them has to be the opposite, right? Make it the same but opposite. It saves us so much, like, possible mistakes, or so many possible mistakes. 15x minus 36. Check my math. You guys know it's never, not always perfect. I wouldn't say never perfect, but not always. Amen. Amen, amen. The older you get, the more the imperfections jump out, but that's okay. Keeps us humble. You guys agree? Cool. Cancel. Negative y plus z equals 3. Oh, that's a nice little equation. But you see the struggle, right? I would love to have one more equation and do this again and get another one like that, right? And technically in class, we would have written this over to the side. We were kind of going like this, so we'd have our negative y plus z equals 3. Hopefully, ideally, if we had another equation, we'd do it again, we get another one. Remember, we'd take these, right? Cancel out the y's, get the z. But it's impossible on this one. So we say, let z equal a. Jacob and Lainey and Mari and others were trying to say, yeah, let z equal a. So what would my row echelon form look like? How do I get the stair step? Josh, head up. Hand down. Too much temptation. Okay, so how do I get my stair step? This is 7-3, the homework you were working on, remember? I need to get one of these guys. Which one do you like better? Second one? All right. But remember, we're supposed to get a leading coefficient technically of 1x. Good. So how do I get a 1 if it is a 3? Divide everything by 3. So 3 over 3 will be 1x. 7/3 x. Oh, y. I apologize. 4/3 z equals 3. Okay. So I have my 1x equation. Now I want my... Okay, but hold on. I want a positive 1. What am I going to divide everything by? Okay. So I'm going to flip the sign of the y, which is now a positive y. Flip the sign of the z, and flip the sign of the 3. And then what's my very final one, since I don't have any other? Z equals a. Now, remind me, whenever you have row echelon form, whenever you have this stair step, why is it so nice? What does back substitution mean? A is going to take z's spot. But I need x and y. That's okay. What am I going to do first? Go find y. Because I can say, well, if y minus plug in a is negative 3, then remember, whenever the a comes in, everybody has a's. So y is going to equal negative 3 plus a. Okay, whatever. Then go take that guy, plug it into the y spot, and Ruth, this is probably where it got messy, was solving for the x, right? X minus 7/3 times negative 3 plus a. That's just plugging in y. Plus 4/3 times a. We need to get x by itself. So we're going to have to distribute this guy. So I have x. Oh, that's not too bad. The 3's cancel, right? And a negative times a negative will be a plus 7. As I come to the next one, negative 7/3 a plus 4/3 a. But if you guys notice, can't I combine my a's and subtract my 7? So I have x equals, won't be quite that mean, minus 7, minus 7. That's going to be negative 3/3. Wait, negative 3/3 a, that's just negative a. Equals, and 3 minus 7 is negative 4. Turns out not to be that bad after all. So then x equals negative 4. And guys, how do we write the answers whenever we have an x and a y and a z? Which one comes first? Then then dun 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 dun. Does that make sense? There we go. Whew, that was a nasty one. Good question, Ruth. Jacob. Yeah. Yeah, you wouldn't have a unique answer for x and y and z. Z would be in terms of y, like you wouldn't have a solution for anybody because it would still be dependent on each other. Does that make sense? We want z to equal a number, but we can only do that when we have three equations and the z doesn't cancel. So if z can't be a number, it's one of those weird like intersecting ones where it intersects not just at a point, but like a whole line. So there are infinitely many solutions. They're just asking, okay, I know there's infinitely many. Once you get here, you know there's infinitely many. But they want to know how they're all related. So we choose that A, and then we get everybody in terms of A to say, cool, if Z is 1, then Y is, then X is. If Z is 2, then Y is, then X is. If you had the other way, well, we wouldn't exactly know what to even be finding. So just remember, let's equal A. Leo. Non-square, or I didn't get to show you an example, but you can go back in notes. It could also happen that when it looks totally normal, so you don't know for sure, like these from the beginning, Z equals A, you already know. But if you're doing one of these guys, and you're like, okay, set those two, get a YZ one. These two, get a YZ1. If you try to put the YZs together, usually Z equals 1, Z equals 5, Z, but if you put the two together and Z cancels, and you get 0 equals 0, or 5 equals 5, if it's true, you gotta let Z equal A. If it's false, say no solution, it's impossible. Good. You guys remember the whole true-false thing that can happen with systems, right? False statement, 0 equals 5, negative 1 equals 3. If it's false, what can you say as long as your math is right? Inconsistent is the description, no solution is the answer. Question, AJ, what was it again? Number? Oh, Lainey, it's number 51. Sorry, AJ, your question was in homework. Number 51. Okay. We're just going to help with the equations and not solving it because you guys could definitely use your calculator on this guy. In your review, you will once again be able to use your calculator tomorrow. However, if I ask you for by hand work, which will be shown by either me explicitly, well, you just say like use substitution, use elimination. If I don't say what to use, you could technically use anything, including graphing and finding the intersection. But if I say to use substitution or elimination, even on multiple choice, I'll be looking at the work. And if the work doesn't match, you won't get full points. Does that make sense? But I will let you use your calculator as long as I am allowed to check for partial credit any problems that tell you to use a certain method by hand. You can check with your calculator if there's time, but you need to do it by hand and try to solve it that way, showing me work. Does that make sense? But if I say solve using whatever method you want, that could include graphing and finding intersections. Cool? Okay. 51. Definitely a calculator problem. What's the total? How much money is there? 40,000, right? How many different investments are made? Yeah, I see 3 different accounts, right? So it got split into 3 different pieces, and I'm not exactly sure how much money got put in each account. It got split in 3 different pieces, totaling the $40,000. How much interest was earned the first year? That's a stinking good amount of interest. You won't find that these days. Anyway, but $3,500 is how much interest they got the first year. Interest, where is interest? Come on, somebody has some sort of financial understanding. And the interest is some sort of percentage, right? I mean, most of you guys are probably more thinking about like buying a car and then thinking about maybe the loan percentage or like a credit card, that percentage. I mean, that's you paying a percentage. But this one, it's you, for interest, you're getting a percentage. So, first account, I don't know, you make 7%. Second account, you make 9%. Third account, you make It's crazy and unheard of, but sure, 11%. Oh. Well, wait a minute. Hold on. That's only 2 equations. Aw, z equals a. I've used these clues. I've used that clue. What haven't I used?
Find the amount placed.
Ooh.
Each investment for the second and third were 3,000 and 5,000 less than the first.
Oh.
Respectively.
Respectively. That's like 2 separate clues, isn't it? So the second, which would be y, is 3,000 less than the first. So x minus 3,000. Does that make sense? The second is 3,000 less than the first, and the third is
5,000
less than the first. Okay. Oh. Question. Couldn't we just kind of plug in, and then just solve for x? Once you have x, couldn't you, and then be done? Cool. All right, kiddos, the review, if you have not written it down yet, we still have 10 minutes. I'm going to give you guys some work time. Hopefully you got that stuff in your workspace, because that will definitely help you if and when you get stuck. On 2 that people who have gone before you are like, these ones were tricky. Otherwise, I would open up your notes. There's not really a lot of memorizing, but is there studying to be done in Chapter 7? Yeah, you have the whole z equal a thing that can happen. You have those new terms of inconsistent and consistent. You have the term stair step. Partial fractions, would that be good to study some? How to make the partial fractions and like which method to go. But what does the review give you? A chance to practice. Ready, set, you got to be productive. On pre-cal for the last 9 minutes of class. I'm going to pull up the first page of the test review in just a few moments when everybody has written it down. If you have a book, cool, use it. If you don't, I'll get it up on the board. So that way we don't have to do the whole like running up, grabbing a book and sitting down. Unless you're like, I'm ready right now and I'm not having the book up yet, then you can come on up and grab a book. If you're ready right now, come grab one. Lainey doesn't need hers if anybody wants to borrow. But as soon as I switch, no one else will be coming up for a book. Actually, there's no good teacher's edition for higher math courses. It kind of says teacher's edition, it looks the same. All right, anybody still writing? Okay. People who are up, you may grab one. People who are not up, too bad, so sad, you can now go ahead and use the screen. 7 and 15 are up, and that's the beginning of your review. All right, guys. No one has an excuse not to be working on the review because it's up here on the smartboard. So either you're working on your workspace because you're behind and you still have to finish 7-5, which is kind of sad. It was kind of an easy homework. And you had 2 days to do it, kind of. But still, you could be working on your workspace. The first one in your review is number 7. The second one is number 15. You guys should have it written down, but that gives you a place to start. If you have any personal questions on anything with Precalc, well, anything in general, raise a hand. I'll come find you. Oh, this is one. I did an example like in class. S is like your Y, so you can plug in. T is like your X, so you can plug in. When you making your equations that you're going to do. Parker's. So I'll do the first one. If you plug in for S, 128, and you plug in 1 for T, 1 will just be everything that's there. 1, I just use the V to make it easy. And there's nothing to plug in. There's an equation. Well, But the long story short, I'm just trying to find that guy, that guy, that guy. So you can put the little zeros if you want, but it makes it easier in my brain if it's just 3 letters. So do it again. Do it again. System of 3 equations. Number 7, I would think substitution, yeah? Solve for x or solve for y and then plug in. I think substitution might be the easiest way. P.S. If you're stuck on number 7 because you don't like substituting or you don't like quadratics or you don't like factoring, all things we've tried really hard to work on this year, you can double check your solution on the board. Hopefully not steal, but double check.